Solve this question using matrix method. We are going to form first a matrix equation. The first matrix we are going to write is the coefficient matrix. The coefficient matrix is 3, 1 for the coefficient of y, 5 for the coefficient of x, 2 for the coefficient of y in the second equation, multiplied by the unknown matrix for the letters x and y, and it should be in form of a column matrix. This will be equal to the constant matrix, which is 7 and 12. We also write it in form of column matrix. That's the second step is to find the determinant of the coefficient matrix. The determinant of a 2 by 2 matrix is given by the difference between the product of the main diagonal and the other diagonal. So in this case, which is the main diagonal? The main diagonal is 3, 2, and the other diagonal is 1, 5. So the determinant of this matrix det is given by the product of the main diagonal, that is 3 times 2, minus the product of the other diagonal, 1 times 5. This will be 6 minus 5, which is 1. With the determinant, we can get the inverse of this coefficient matrix. For us to get the inverse of the coefficient matrix, we interchange the main diagonal. Here we have 2 and here we have 3. So we take 2 and place it 3, and then the position of 2 is occupied by 3. So we write 2, 3, and then we reverse the sign of the other diagonal. Like in this case here, we have positive 1 and positive 5. We write it negative 1, negative 5. The last step for the inverse of the matrix is the new matrix formed, we divide by the determinant. In this case, the determinant is 1. So as you know, any number divided by 1 is the number itself. So our inverse, the inverse of our coefficient matrix, is 2, negative 1, negative 5, 3. Now the next step is to take the inverse and multiply both sides of the matrix equation. So we'll have 2, negative 1, negative 5, 3, multiplied by 3, 1, 5, 2, xy is equal to 2, negative 1, negative 5, 3, which is the inverse, multiplied by the constant matrix, which is 7, 12. Look at the left side of this equation. If you multiply an inverse and its matrix, we will get something, a matrix called identity matrix. Identity matrix is a matrix that has 1, 1 in the main diagonal and 0, 0 in the other diagonal. So the result of multiplying these two will be 1, 0, 0, 1, and then multiplied by xy is equal to, if we are multiplying two matrices, first of all, we check their compatibility. Now, we state the order of the first matrix. This one has 2 rows and 2 columns. The order of that matrix should be 2 by 2. This one has 2 rows and 1 column. Its order is 2 by 1. So if you look at the column of the first matrix and the row of the second matrix, if they are equal, then we can say that two matrices are compatible, and therefore we can comfortably multiply them. Now, how do you multiply? Each row is multiplied by a column. We have got 2 rows. So the first row will multiply with a column and then go to the second row and multiply this. So let's be very fast in multiplication. If you have never multiplied two matrices before, I will refer you to one of my videos and put it in the description. So watch out that video before you start watching this one. So the first row is 2, negative 1. We'll multiply 2. We take 2, multiply 7, and then we add multiplication of negative 1 and 12. We are through with the first row. Then we come to the second row. We take a negative 5, multiply 7, and then we add, take 3, multiply 12. On the left side, if you take the identity matrix I and multiply any matrix, let's call it M, the result will always be M. That means it doesn't change the matrix. So if I take the identity matrix and multiply XY, the result will be XY. So on the left side, we'll have XY only. When you come to the right side, this is 14 plus minus 12 is the same as 14 minus 12. So that's the same as 2. This is negative 35 plus 36, which is the same as 36 minus 35. That gives us 1. Finally, X will correspond to 2, Y will correspond to 1. Therefore, the value of X is 2, the value of Y is 1. If you have any question, please leave us in the comment section. Please subscribe.